Welcome everyone to my channel Space Remote Sensing and GIS. Today we are going to discuss of another spatial analytics techniques that is called 3D modeling technique. So here in this case we are going to use the data visualizations, how it is helpful for us to do the analysis, so that we will going to discuss. So for that, if you see here, I'm going to use few data sets, like we are going to use here as a digital elevation data, hillshade data sets, and we have so two important data sets. One is the earthquake magnitude data, as well as we have the building damage informations due to the earthquakes. So now we will going to show you how the 3D based spatial analysis, which will helpful to understand the data. So it is also a part of spatial modeling techniques, which is helpful for the data visualizations. So my first objective is, see, this is my 2D informations. As you've seen, this is my 2D data. So what we need to do, that is we need to convert it in a 3D. So earlier in my old videos, you already understand these techniques, like how to convert the 2D informations to 3D, but as for this particular analysis, we are going to show you the conversions of the 2D to 3D informations. So to doing that, the very first things which you need to do, that is you have options over here in a view, and you can convert this 2D informations to the 3D. So there is a both informations will be there, the global scene and local scene. So when you have the larger area, you want to do some analysis when your data sets is covering almost the full world, so in that case you can go with the global scene, but in this case we can use the local scene for the analysis. So I'm just converting my 2D scene to 3D scene. Let's wait for the results. So as you've seen here, now this is my 3D scene, which is just open it here now. Now the next important things which you have to do, see here, once I will convert it, this is the world data sets. If you see here, there is a world data sets which is already there. If I open the property, I can show you this is directly coming from your ArcGIS Online. So using this also you can convert it the 2D data to 3D. But if you see, this is coming directly from the ArcGIS Online. So but what we don't want this 3D to convert it in this particular DEM, world 3D DEM, because this is a 30-meter resolution DEM. But what we want more higher resolution of DEM, so which we have with us. If you see this particular elevation layer, which we have a more you can say the resolution. So for to seeing that, you can go to the property, and if you see here, we have a raster information, and which is showing clearly it is almost 9.5, means 10 meter to 10 meter pixels. So we have the 10 meter pixels DEM. So why not we are going to use this particular DEM to converting my data sets in 3D, insist of the by default DEM, which is provided by the ISRI. So that is the world 3D DEM. So to get a better, suppose if you for your study, if you have the better quality of the data, so obviously it is better you can use that high quality DEM for this particular analysis. So to doing this, first thing you have to do, that is you have to switch off this particular world elevation DEM, whatever it will be there. And then you just right click on this, and you can click this here as a add elevation source. So once you click this as elevation source, so now you have to go to this particular data sets to select that particular DEM. So this is the elevation 83 DEM, which is this particular DEM, which is this particular DEM, which is representing here. So I'm just simply click on OK. Now it will take a few seconds time to add this DEM as a source. So now you see my elevation 83, which is added is as a source, means 80, that is basically the 10 meter resolutions, which is now converted in a DEM. Now if I just press your mouse that wheel button, and you see this symbol will come. So if you drag it little down, so it is converted in 3D. So if you zoom it, so you can able to see this as a 3D layer also. So that is the most beautiful thing over here, how you converted the 2D scenes to the 3D scenes. So this is the way first steps which we are going to do for the data visualizations, okay, to converting the 2D scenes to 3D scenes and make your high resolution DEM to visualize it in a better way. Okay, so now the next thing is we have this 3D information, sorry, we have this 2D informations, which is basically my node bridge. Okay, so this is what you seen it here. Okay, so this is my node bridge, that one, this layer. Okay, so in a feature layer tabs you see the options like how we are going to convert it in a 3D view. Okay, so this 3D view is not representing the building height. So what we are basically trying to explore it here. So if you see the attribute, okay, so this is going to represent to you about the data, so that you have to get some idea about the data sets. Okay, so here we have the damage informations. So what I want is, using this damage informations, we have to create the 3D, means more the damage building, more the height. That is what I want to represent. Okay, so if I want to do that, then what should be the process? So the process will be, if you see here, I'm just going to select this, go to the feature layer, and you have options over here. Okay, so here you see the none, minimum height, maximum height, baseline, and absolute height. So 4 options will be there. In this case, I'm going for the minimum height options. Okay, so just click on that. Okay, so and you will see your layer will be something looking floating over this particular surface. Okay, so this is the first steps which we'll see over here. So that means now this layer will come to your 3D layer. You see here it is coming on your 3D layer. Okay, now the next is we have to convert the unit to represent in a high height. Okay, so for that you can use a particular formula for visualizations. Okay, so if you click this formula, okay, so here you have the unit values. Okay, so suppose what the unit which you want to target, that is the damage. Okay, damage building. So here both options will be there. Either you can go for the ArcD or you can go with the VB script. Both options will be there. Okay, so you can use any one of them. So I am going to use the VB script, suppose. Now see, when I click the VB script, this is what the unit will come. So I will remove this. I will going to target the damage building. Okay, now what I want, suppose I want, so whatever the values will be there, I want to scale it, means 25 times I will increase that value. Okay, so that I will see the height properly over this particular area. Okay, so for that I will just multiply it with 25. Okay, so if I do that, simply click on OK. Okay, so now you see this is how my building height will come. Okay, so my building heights will come over this particular, this is called how the data visualization technique. So you can make it more visualized, better to change the symbology. So if you right click and go to the symbology, so if you see here you have options for more. So what you do, you can go for the format or symbols, all symbols, and here you can go in a property, and this one, this outline color, you just make it as a none. So now you see your looks will be much more better than the what you've seen in the last. Okay, so you see here this is very nicely, it is showing the visualization, and data visualization is quite nice, good. And you see here the color which is showing the more the height, okay, and more darker value, which means the more the damage we can see due to the earthquake in this particular locations, more the damage will happen than the surrounding areas. Okay, so this is the very first steps of our analysis, like how we can use the 3D data visualizations for the spatial modeling and understanding about the data sets. Okay, now suppose we have this earthquake layer data, so which we'll have in a 2D layer, so that we want to represent in underground. So in that case I will just simply drag this earthquake data and put it over here. Okay, in the 3D layer, you see now my point data will looks like a floating like this. Okay, you see here it is floating like this. Now how we will going to represent this? This is basically the source of earthquakes. Okay, so if you see the unit of this earthquake, so it is basically going to show you the depth. Okay, so in which depth this source of the earthquake is actually going to happen, so that information will be there, and that you want to represent in underground, because depth is always in underground. Okay, so that you want to represent, suppose. So in that case the process will be, see here, if you just right click here, also you have options, okay, to represent your data sets. Okay, so just see on this to open. Now once you transfer it here, as you seeing it is coming in the 3D layer, so you just need to right click, go to the property, okay, and in property you have these options called elevation layer. Okay, so now you have to change this to in the relative to the ground. Okay, yeah, so this is what you see here. Now the elevations, and now I'm changing to the on the ground these options. Okay, so we have these different options related to ground. So basically if you see here, we are basically going to select this one, the absolute from the height, the feature with exact height such as the airplanes. Okay, so we are going to use this one, okay, an absolute height. Okay, and the next important things which you have to do, that is we have to change this vertical unit from the meter to kilometer, because the high depth is actually measured in a kilometer, so you have to convert it in a kilometer. Now you can put a expression. Okay, so in the expressions here again you can select any one of the formula technique. Okay, so that will be fine. So main thing is you have to then representing something in underground which is depth. Okay, so if you want to do that, so better is whatever the values will be there in a depth, multiply it with -1, as we already converted in a kilometer, so the representations will be in a kilometer. So simply click on OK. Okay, so this is how, and you can see simply click on apply and go for OK. So you see the representation. This is how you can represent your data in a 3D, both the above surface informations and below surface information. So two important things which we represented here. We are taking a data, okay, which is one is representing the above the ground, okay, above the ground 3D, and the below the ground 3D, and how we are going to interact that informations to represent. Okay, so that is what we generated over here. And if you want to compare this 2D results, this 3D results to the 2D results, you can very easily do that. Simply drag this and put it in a right side. Okay, so you see here now my 2D and 3D I can compare together. If you want to make a connection also, that also you can do, okay, in a view. Okay, so this is, you see here view link. If I go for the center and scale and see, so if I zoom in one place, another place it will be zoomed. Okay, so this is the way I can compare the 2D window 2D data to the 3D data for the spatial analysis and modeling purposes. So I hope this video will be very useful for many people who are interested to play with their data, okay, and do some kind of 3D based analysis and modeling. Okay, so in this case this visualization techniques is also very helpful for different kind of analysis, as you've seen here. Okay, so the more the depth of the earthquakes, okay, so we can measure and we can understand about the maximum place where the earthquake damage is also happen. Okay, so this is all from my side. So if you like this video, I will request you please share and subscribe my video, and please give comments on your on this particular video. Okay, so I'll see this people are watching so many videos. Okay, so you are not giving any comments, so I'm requesting you just give a comments, okay, so that I will get more motivations. Okay, and please subscribe and like my videos. Thank you very much. This is the only things I need for my motivations. Thank you very much all.